So coming to today's topic, that is FEEDEX HD or spot risers. We all foundrymen call it in terms of spot risers. We have seen a tremendous increase in its usage over the last decade or so. And the main reason why, yes, the SER and casting production has increased, and that has helped in a way. But the main reason why this has been so is specifically because its ability to eliminate shrinkages, eliminate defects from the casting, and thus improve the casting quality. And while we are doing so, it also helps in improving the productivity of the foundry, improving the yield, eliminating rejections, reducing fettling, thus in turn simplifying the process and bringing in the consistency. So in today's presentation, I will holistically cover this product technology specifically for iron castings, and we'll keep the flow as this. First, we'll understand the challenges in feeding. What are the different challenges development person faces while methoding an iron casting? And typically, what practices are used in order to eliminate shrinkages, in order to improve the soundness? We will look also into that. And these two parameters actually will give us an idea as to why and how the development or the design of FEEDEX SD was done. Further, we'll look into the product technology, its features, its application, and the benefits that the foundry can get from it. And with respect to these benefits, we'll also have case studies. In the end, I will share the kind of value creation we can achieve with this with the usage of this product. And finally, I will close with how we as Foseco support our foundry customers in terms of methoding. So getting started, first the challenges in feeding, especially for an iron foundry. First is the casting standards. Here we need to talk about firstly the casting quality requirements, which have been getting stringent. Secondly, it's always a drive from the OEM that they always want to reduce the weight of the castings. What it gets into is that we have components which are more complex, which have more isolated hotspots, and in turn, because of this complexity, there will be a lower footprint on which we can place a riser or a feeding head. So this is one, that is the casting geometry and the requirements. Secondly is the molding line. Now, especially for iron casting, most of the castings nowadays will be produced on conventional jolt squeeze lines or high pressure lines. So first thing is to withstand that squeezing pressure, and secondly, we need to understand with respect to each molding line the accessibility of pattern, the accessibility of mold in order to place the sleeves or even the riser. And thirdly, the fettling and cleaning. And especially this is sometimes overlooked because in the end, uh, we sometimes we method the casting, we get the casting okay, but what we find is due to the heavy risers, the higher number of risers, or even if the neck sizes are on the higher side, the fettling time will increase, and that will be a bottleneck for the supply of castings. And not only that, it will also affect the aesthetics of the castings, which even now some OEMs are demanding that the fettling marks should be kept to the minimum, at least in some surfaces of the casting. And finally, the evergreen topic of productivity for a foundry, wherein uh, it is always a requirement that we produce castings with optimum yield, minimize rejections, and thus in turn save on the cost, increasing in the cost of raw material or energy consumption. So these are the four parameters a development person looks into while methoding a casting, so that it is, of course, it is giving a good quality casting with optimum yield and thus being economical for the foundry. considering all these aspects, typically we give some changes to the methoding or apply some changes to the methoding so as to eliminate the shrinkages or uh, uh, improve the soundness. So before I share, I would like to everyone to participate here and share their experiences as to what the changes they made in the methoding so as to eliminate shrinkages or found in the foundry. Anyone can start. You can unmute yourself and share your experience.
Hello. Please share your experience, sir, asked by the speaker.
Anyone? Or should I move forward and we can take it in the later part then? Well, I'll share my understanding and then we can in the end have a Q&A at the end. So typically what foundries do is go for heavy rising. That is mainly because they want to eliminate shrinkages. And in the end, what it happens is that they will reduce their yield, reduce their productivity, and in the end, the overall production capacity for good casting will be reduced. That is one area. Secondly, in some cases, like this hub or specific cases, if we talk about diff case casting, many a times padding is required for directional solidification, and what it does is uh, it results in heavy fettling, and not only that, after the fettling, we need to machine this extra pad. So it will be adding some cost and time as well during machining. And one more aspect is the usage of chills and profile cores. And in terms of chills, considering for say iron mass foundries which are producing casting in numbers say 10,000 or more, uh, stocking of chills, handling of chills, then the reusage of the same is a tedious thing, and it will be tricky for the foundry to keep a proper stock of the correct usage of chills. Secondly, sometimes foundry use profile cores, and what it does is if there is a mismatch between the core and the mold, or even if some change in the peg design or dimensional tolerance is different, what it will result in mismatch between the casting and the riser, and in turn the dimension of the casting will get affected, which even might cause rejections to the foundry. So all these practices what we saw uh, actually cost the foundry but also are tedious to handle. That means we'll have inconsistency because of these. So in order to avoid that, FEEDEX HD, in order to withstand the squeezing pressures, high squeezing pressures, a high density sleeve which will have high strength was developed by Foseco, and it will have the lowest footprint area. That means we can find soundness even in the complex isolations of the casting. That is how the concept and the design of FEEDEX SD was developed. And a brief uh, about the unique design of this product. So we can consider it in two parts. First is the sleeve, and it is glued with a collapsible compressor core, which is made of steel. And if you see the design of the sleeve, as we go upwards, the thickness of the sleeve will increase. What it does is it will provide a superheat at the top face here, and thus a directional solidification is achieved. And in terms of this, uh, we actually find flat feeding we using these kind of sleeve risers. In case of sand risers or even conventional regular sleeve risers, you will always find V-shape feeding, but for FEEDEX SD, you can find flat feeding. And with respect to its highly exothermic properties, we can achieve an MEF of around 2, which is unmatched, and MEF is the performance indicator for a sleeve we use, modulus extension factor. For regular sleeves, it will be varying from 1.5 to 1.7. And for FEEDEX HD, we can achieve at least 2 and even 2.4 in some cases, in some sizes of the sleeve. So regarding the application and benefits, uh, application wise, most of the foundries now are much aware of this. I'll just cover it in a few minutes. So we use locating pins on the pattern and place the sleeve riser, FEEDEX HD riser onto it. This locating pin is used during ramming, and this is how the mold will look like after molding. And this circle is actually the compressor core part. After shakeout and knockoff, you will find a riser residue of less than 1 mm, which can be easily grinded off. And the knockoff is also very simple because the diameters are very less. A small video of how the compression takes place during squeezing. Now, in terms of benefits, what of course we are going to achieve soundness in the casting, but with that, we'll mostly in case of a FEEDEX HD method, will achieve the highest possible yield, and that too with the lowest footprint riser. That is, the fettling, the knockoff of the riser will be very much easy. It will have consistent performance, and as I said, soundness in difficult to feed geometries, and that too without affecting or having any adverse effect on the metallurgy of the casting near the neck or the riser. A very important point to note for the foundry. So over these years, uh, uh, as we went on to develop new customers, we actually have been successfully implementing this FEEDEX HD riser on all the type of molding lines, be it hand mold or the conventional jolt squeeze line, ARPA line as we call it, or even the high pressure lines, be it vertical, be it horizontal, or even flaskless with flask. All the kind of lines we have covered, and application has been successfully implemented uh, for green sand lines. Barring a few lines, say some Cinto makes which are of older version wherein the pattern plate is not accessible, only barring such lines, but most of the lines have been covered. Now moving on to the product range, so we can divide it into two parts. One is without the compressor core, which we call as FEEDEX HD VS or FEEDEX HD G, and one with the compressor core, steel compressor core, that is FEEDEX HD VSK or FEEDEX HD GK. So for hand molds, we'll always use the sleeve with a regular sand breaker core, as there is no squeezing pressure. And for squeezing pressure lines, that is HPL, we'll go for the collapsible compressor core. That is the main difference. Now, moving on to the benefits and case studies related to it. First is the main benefit is the yield that we are able to achieve while moving from a conventional method to a FEEDEX HD method. So comparatively, if you consider if you are replacing a sand riser to a FEEDEX HD riser, the weight of the riser will reduce to 10% of what it was with the sand riser. So you are using an 8.4 kg sand riser, then you can shift it to an 850 gram of FEEDEX HD riser. That is the kind of benefit we can achieve. Not only that, in terms of efficiency of the riser as well. For sand risers, you can consider the efficiency up to 10% and max up to 15% if you are using it as a hot riser. But in case of FEEDEX HD, the efficiency will be as more as 50%. And in some cases, we have also achieved 60% efficiency. But the threshold we consider 50% because many a times it can be a case where the if the riser drain out is more than 50%, then there are chances of shrinkage. So in terms of this yield benefit, here is a case study of a rotor casting, and this is being mainly produced on no-bake molding. So previously, the customer was using side riser method along with running system. The size of the riser was 100 by 150, and what we did was we shifted it to top risers, uh, six number of FEEDEX HD, that is VS283, and one Kalpur ND unit as well. So that also contributed to the yield, but the main benefit of yield was achieved through the shifting of side riser to top riser and using FEEDEX HD. And to share with you, the benefit that we got was the reduction in the bunch weight from 410 kg to almost 254 kg. That is 150 kg saving per casting. And what it really meant for the foundry was it doubled their productivity, as in one hit, if they were producing only two castings, now they were able to pour four castings. Another similar case study on similar lines, shifting from the side riser to the top riser. This is an H-link casting, firstly produced by a 10 by 13 side riser. We shifted it to a FEEDEX SD VSK240 top riser, and with that, without hampering the casting quality, we got NSD casting in the first attempt only. We are able to achieve a 40 kg metal saving in terms of yield. These are the actual pattern photos of that method. Now moving on to the second point, that is of fettling. Here you can see in all the images after the riser knockoff, the residue that remains is absolutely minimal. Even in some cases, it is less than 1 mm. So you can imagine that there is no fettling required after the knockoff, and these all risers can be easily knocked off using a hammer. Why? Because the maximum neck size with for which we use FEEDEX SD is 30 mm, which is easily knockable with a hammer. In terms of this, here is a case study of a hub. Previously, the customer was making the same casting with direct pour unit at the center and four regular conventional risers with sand breaker core. We shifted that to a FEEDEX SG riser. What we are able to achieve with that was, firstly, the padding that was required at this step, that was eliminated. So we eliminated the machining cost, and not only that, the fins that were generated during the actual operations using conventional sleeves, that were also eliminated. So it was actually the demand of the OEM here who drove this project, that they want to eliminate such fettling marks and even the machining of the casting. Another similar example of a flywheel casting. So previously it was a two cavity layout, and it was fed by a Kalpur 9 by 20 size. And here you can see that the neck size, that it was covering all the three steps of the casting. You can imagine the kind of fettling work or the machining work that was required for this casting. The main reason why we can attribute this kind of neck is in this casting, the hotspot was towards the ID. So feeding it from outside will definitely require heavy padding so as to have directional solidification into the Kalpur riser. Instead of that, we went for a FEEDEX SD method and directly placed the FEEDEX SD on the casting on top of it, thus having a better connectivity to the hotspot, and not only eliminating the defect but also eliminating this extra padding and the machining costs associated with it. What it actually meant for the foundry was previously their casting was staying in WIP for almost 2 weeks, and now with the FEEDEX HD method, it is being available for dispatch only on the fourth day. That was the difference we achieved. So moving on, I will cover the main benefit uh, of uh, of this product, that is FEEDEX HD. And as I said earlier, considering the complex geometry, the isolated hotspots, instead of using all these tedious uh, solutions, FEEDEX HD application with a simple pin design can really help not only in improving the soundness of the casting, but improving the ease of operations for the foundry. So in terms of that, here is a case study of flywheel casting, flywheel housing casting, and this actually was a NPD project, and the casting weight is around 40 kg, and we had to put three risers, three FEEDEX HD risers, which actually was a cost for the foundry. Uh, but still, actually, they went for this method only for one reason, that is the productivity required, or the number of castings they needed to dispatch per month was 9,000 numbers. And for that, they needed a two cavity layout, and hence FEEDEX SD method was the most suitable method for such productivity requirement and the casting requirement, that is no defect at radiography level. Of course, we can method this casting with side risers. However, it will consume a lot of space, and thus we'll have only single cavity layout in that. And here are a few examples more of similar castings produced by different other foundries as well, flywheel castings, and all of them are using FEEDEX SD methods. Another similar case study. This is of hydraulic castings, hydraulic housings, and actually this was the drive from OEM again because of the NSD requirement, because these castings will be pressure tested, and
Mr. Ravichandran from Southern Alliance gave a question in the chat box, sir.
Okay.
He gave please share the dimensionals and models of HD feeder.
Share the dimension and modulus of HD feeder. So we have a separate product data sheet for this FEEDEX HD. In that, you will also have the dimensional details and the modulus with respect to each size. We'll share it with you, sir.
Then he gave another question. How
Huh.
many times chills are used?
Huh.
There is any extra research papers related to chill usage? What happened? The efficiency of chills with respect to number of time usage.
So, in my experience, say if a chill is used more than 10 times, then the effect will reduce drastically. After that, it will be difficult that the chill will provide directional solidification, or actual the chilling effect will be there. But any technical papers as of now, I don't have any. But in case I come across, I'll definitely share.
He's asked
One
another
more.
one more question.
Ha, ha, ha.
Is it preferable for medium weight 50 to 250 kg and above 250 kg casting?
So it is actually definitely preferable. And even in one case study which I had shared, the casting weight was around 220 kgs. This one.
Okay.
So actually 50 to say uh, not 50, say 10 kg and above to up to 300 kgs. The application is very much viable and economical as well. One more question was there from
Yes,
Ravi Shankar
same
sir.
person.
Huh,
What is the percentage of exothermic material?
uh, this detail actually I don't know. That the recipe part we actually do not know. The application and the usage we'll be able to answer.
Sir, are there any further questions for Mr. Rohan? Okay, if there are no further questions, I think we'll move on with the vote of thanks. So, gentlemen, we have had a very interesting webinar today on the topic FEEDEX HD. We are sure the contents of the talk had a lot of takeaway for our audience. It was a very interactive and interesting program. And this was the 49th program conducted by the Institute of Indian Foundrymen Chennai Chapter this year. So, yes. And we would like to thank our speaker for the day, Mr. Roshan Joshi, Senior Manager, Application Engineering, Iron Methoding, Foseco India Ltd, for taking time off his busy schedule and making us rich with knowledge. This is the second time Mr. Rohan is taking a webinar for Chennai Chapter. Last year, you spoke to us on metal filtration, and this year on FEEDEX. Thanks a lot for your time, sir. Both were very interesting presentations.
Thank you. Thank you
And
very much from my side as well, and for the
yes, sir. Yes.
opportunity.
And further, we would like to thank all the members who joined us for this talk. I'm sure you had a wonderful learning experience. And thank you for joining us on time and being such a wonderful audience. We from the Chennai chapter will be conducting many such interesting programs, both physically and virtually. And we will be sharing the information with you soon. Looking forward to seeing you all in our upcoming programs. Thanks so much. Thank you, everyone.